Okay, Bismillah ar-Rahman rahim. This is the binary tree program. It's an array representation of binary tree or binary search tree actually. So we're gonna here do what we have declared an header file, a maximum true equal to 1, false equals to 0. Then I'm gonna have two things. One is info and one is used. Info is the data what you want to put in, and used is you want to say with every element that is it filled up or not. If it is filled up, any node which is filled up, we say used is 1, otherwise it's 0. So then we go to the main. We have the main program which is here, right? So here I declare two variables p and q. P will variable will have the it will point to the parent node, and q will point to the child node, whether it may be left son or right son. Okay, so first I'm asking the root and putting the num and setting the make tree. Make tree actually initializes my tree, sets the root node, and all other nodes their used will be their used will be 0. That is false, like here. So I'm saying make tree entire node of 0.info. I'm sending it that data value, the node of 0. I put that in a 0 value. That's my root. Say for example I put in some say I put in whatever, like 10, like I put in 10. Okay, in my this value I put in 10 here. This is my root. So if this is a binary tree and binary search tree, what you're gonna do is we have the left son and right son, and left son will be p twice p plus 1. Okay, and right son will be twice p plus 2. If it's a right son, that will be twice p plus 2. If the p is 0, for example, 0 into 2 is 0, plus 2 is 2, that is this one, and similarly this one will be left child. Okay, so what I've done is I filled up with here. I'm filling up this value of x, that's 10 for example, which I got in the main, into the root portion. Okay, then that's my node of 0 to x, info is equal to x, and node of 0 to used is equal to true, and the true used value of this node is set to true. Okay, then from 1 I is equal to 1. Remember, this is 1, not from 0, because 0 is the root we had done it with, and rest of the nodes unki jo hamare paas used hoga, it is set to as false. That means 0. Okay, now we go back to our main. This is what we did here. Make tree, line number 59, make tree, and what has done, root node has been set, and rest nodes will have in their used 0. I'm asking the user to enter the data into the tree, but you can control Z or end of file. When you press end of file, you get out of this white loop, outer white loop. So what I'm doing is I'm initializing p and q to 0. Let me start up. Yeah, I'm starting from the root. Okay, then I'm saying if q is less than max, that q should not have gone beyond the array, and node of q dot used not equal to 0, or I can say dot used only. It should be have something if you want to compare with it, that it should have there something, and num, whatever you put in here, that should not be the duplicate. This is for duplicate. This is for is there something or not. If there's something we have to compare, should I go to the left or right? If there is nothing, we should put in there. So what I'm saying, first p is 0, q is 0. That means we are talking about root node. Okay, is node of q means node of 0. That means root dot use it true. Yes, that is, because that is set by the make tree, because that is true, right? So we say p equals q. This time there will be no effect because p will be 0, q will be 0. Now I'm saying if the number I put in, say if I put in the number, say for example 5, okay, that's going to be less than node p of dot info, right? It will be less than. So node p is node 0 this time, parent is 0. That means root node का info जो है उसमें 10 है, क्या number 5 उससे छोटा है, हाँ है, तो we should go to the left child. How? q equal to 2 into p plus 1, it will go to the left child. अगर बड़ा होता तो it will go to the right child. But it will carry on because I don't have to state here, because this time it will get out of this. It has done it. That means q has gone to the 1. Q has gone to one portion, right? Q has gone here. If for example the number I put in is, say for example 5, so if I say 5 is less than 10, okay, that is node p dot info, what we're talking of here. So it will go to the left child. So q becomes this guy. Okay, then in this when we come back to this while loop, this condition becomes false because node of q, that is node of 1 dot use it is 0, right? It is 0. it's not 1 because there is nothing here, so it will get out of this loop. It will come here. I'm saying again, क्या ये num info के बराबर, तो ये 10 के बराबर तो नहीं था, वो नहीं था, क्योंकि अगर होता तो ये डुप्लीकेट देता. ओके, अगर छोटा था, हाँ छोटा था इस वक्त, तो ये चीज होगा, सेट लेफ्ट को कॉल होगी and it will drop what it will do, it will drop here that element in the set left 5 for example. Okay, अगर right होता तो ये यहाँ पे डालता. Okay, it will go back to the while loop. Okay, it will go back to the while, because I wanna fill more nodes. For example, it will go back to this while loop here. It will initialize again pq0, set वापस q तो यहाँ पे गया था, it come back here, p will be here, q will be here at the 0 position, right, both pointing to the 0. Okay, so now say for example I put in some element, say what is that, say I put in 6, I put in element 6, say for example I put in element 6 here. So q is not gone, array and node of q of 0, node of q dot use it, that means this time 0. Yes, that is true, yes that is, and we don't have put a duplicate, so it goes down, it puts p equals to q, means no fark, 0 0. Now num, that is 6, is that less than 10? Because node p is 0, is that less than 10? Yes that is, so we should go to its left child. So it will go into this, q is equal to 2 into p plus 1, that means that becomes 1, q becomes 1, so q is here. But it will not stop here, because it will go back to the while loop. Okay, now this will be, you know, you see why we did this, because node of q is this time 1 dot use it. Yeah, that is also true, that's also true. So that means हमें इसमें data नहीं भरना, हमें आगे चलना चाहिए. Now here it goes down, p equals to q, p has come, p will come down, q is here, p will also come here, p is equal to q, and q हमें क्या 3 पे जाना है 4 पे जाना है, it will decided by the data is 6, so 6 is greater than, so here we will see that it will not go this and go this, because now is greater than node p of info, so we should go here. So it's q is equal to 2 into p plus 2, p is here, this time here 1, so 2 into 1 is 2, 2 plus 2 is 4, so it will go at the 4th location here. So q is here, so p stays at a parent and q has gone here, right? Now it will come back. Now this time node of q dot use it is false. Now it has to get out of this loop, because we have reached the q where we should drop in, so it should go out of the loop. It's going out of the loop and it will go here, it chucks the duplicacy and it drops exactly set left or set right, because this time it is set left, so it calls the set left, sends the parent and the number. Okay, we can change it later on, we can don't need to say p, directly send the q and drop in there, but I'm sending p here. Okay, so I'm sending the p the parent, so I have to calculate q again, then right or left, and then accordingly I will do what, I will drop in there, and make its user true. That's what we do in a set left set right, that's quite obvious. You drop in into the q element, say for example 6, and so you will say node of q dot info equals to this number, and node of q dot user equals to true, so this is true, this time filled up. So it will go, do the set right, it comes back here, and where it comes back to this while loop, gets another number, say this time around I get the 20 for example, I get the 20 for example, I get the 20. Okay, and we'll come up here, p and q again initializes, clears them, p and q both here, right, get them back, and say p equals q if num is less than node of p dot info. Yep, so it should go here, because it's 20 this time, so it will do this, it will go to the right child, so 2 into p, 2 into 0 plus 2 is 2, so it will go here, and now its node of q to use it is not true, so it's 0, so it comes out of this, it will see should I go to the left or right according to the info. So definitely we should go to the right this time, and it will set in here. In the right, what we do, let us see what we'll write and do is actually it drops in data, and it will drop in data as we go here. This is my set left, for example, this is set left. What it does in a set left, it clears a q, because we have sent the parent, so it calculates the q 2 into p plus 1 and checks whether the q has gone the max, so it will say overflow, otherwise, you know, he say node of q dot use is true. Okay, if node of q is true, because if somehow we're dropping somewhere that which is true, it's already true, so we should say invalid insertion, otherwise actually it will do this, node of q dot info is equal to x and node of q is equal to true. Okay, basically it will do this thing. Okay, and right will be same thing, only difference will be it will do 2 into p plus 2. Okay, q it will calculate as a right child, it will do plus 2 here, only difference other than same. and sending parent and the value which is to be inserted, checking for overflow and invalid insertions, otherwise it will work fine. Okay, so similarly it will do it here, and set right, set left, and then we display. That's as simple as it is, right? So I think it will work if you drop in the data. Okay, if you run it now, time to run it. Enter the root. You are trying to enter the root. Say root is my 10, then I go to the left child, say for example 5, then I'm putting the 6, then I'm putting say less than 5, that is 4, that should go to the left of the 4, and then I go to the 20 on the right, that should go right of the 10, and say 15 left of 20, and say 25 right of 25, right? And I say Control Z to get out of it and display me. Oh ho ho, there is some problem. Let us see what's the problem. It is, I guess, the problem Control Z, because I put in Control Z with the number, so it gives a problem. So I say first the 10, then this is the root node. I go to the left, say 5, I go to the left and the right of the 5, that means 9, and 4 to its left. Okay, then 20 to the right of the this 10, it should go to the right of 10, 20, 15 will go to the left of the 20, and 25 should go to the right of the 20, right? And if I do Control Z now to end this loop and to display, we got here. So first of all, let me do this also. We see here this 10, 5 should be here, 20 should be here, and this time I want to say 9 here, 9 should be here, and then a 4 should be here, and 25 should be to this portion, and 15 should be to this portion, right? So that means 0 position 10, 1 position is 5, as you could see here, 2 position is 20, 3 position is 4, 5 position is 15, 5 position is 15, that's this guy, right? Perfect. And 6 position is 25, 6 position is 25. Okay, okay, so it's giving perfectly. So 10, 5, 20, 4, then 9, then 5, 15, and then 25. So it's a perfectly in a binary search tree. So this is how we do it in an array. Now we're gonna do it with the linked list, and also see how we do the traversing, like in order, traversal, pre-order, and post-order, and implement in the linked list basically. Okay, because if you don't fill up the things, the array will get unused boxes, unused array elements, and if you want more and you have only 10 blocks, so you can't work out. So that's why we're gonna go for linked list. Okay, that's all for today. Thanks for watching.